Hello. So let us solve the problem now. So these 3 points in a space are given to us. The first thing we want to answer is that if the angle A is a right angle or not. Of course, this makes a triangle for you in a space. You don't need to be precise in drawing your picture. So just sketch something to understand what is going on. So I have this A, B, and C. Okay, I want to somehow know that if this angle is 90 degrees or not. Of course, this is a very standard problem. So you need to see that if the vector, for example, AB and vector AC are orthogonal or not. So what I do, I use the idea of the dot product. So this is very famous. Whenever you want to see if two vectors are orthogonal or not, you just dot product them. If the answer is 0 and the vectors are non-zero themselves, then the conclusion is that these two vectors are perpendicular. So what we do is to find AB. So AB is a vector, so it includes 3 components, but the components of my vector can be derived from the coordinates of the endpoints of my vector. How? By writing the coordinates of the first point of the final point first. So here 1, 4, and 2. The coordinates of point B minus the coordinates of point A, which is the initial point, 0, 2, and 0. So this is very simple. So 1 minus 0, 1, 4 minus 2, 2, and 2 minus 0 is 2. So that is my vector AB. So usually in the book, we actually write them in the column form. So this is my vector 1, 1, and 2, vector AB. And I do the same thing with vector AC. So the final point here is C, it's 1, 1, and 1, minus A, which is 0, 2, and 0. And then what you get is 1, negative 1, and 1. So if I want to write it in the column form, this becomes 1, minus 1, and 1. Okay? And now I need to dot product these two vectors to see if this is 0 or not. So I dot product AB and AC. So you know the rule. The first component multiplied by the first component. The second component multiplied by the second component. And finally the third component multiplied by the third component, which is 2. And I have to add them. The answer becomes 1, which is not equal to 0. So this means that my angle A is not equal to 90 degrees. Very simple. Okay, now we want to find the surface area of this triangle. Okay, so what can I do? That's also one important thing that you need to know in this course. If you want to find the area of this triangle, you cross product these two vectors. Any two vectors will work. So we have already calculated AB and AC, so let me use them. I cross product these two vectors. It of course becomes a new vector. Then I calculate the norm or the length of that vector. The number that you get is exactly equal to the number of the area of the surface area of my triangle. So what I do, I would say that, okay, the surface area is equal to 1/2 the norm of this cross product. Yes, I have to calculate. Okay, so first thing that I do, I calculate AB cross AC. Okay, I am more comfortable, so I go to a scratch work. So I have AB first because it matters. Here, of course, you are calculating the norm at the end, so the order doesn't matter. But you know that if you just do it the other way around, you pick up a minus sign. So you have to be careful about in those cases. But here, of course, it is irrelevant. So I would do this. I would write the components of my first vector in a row, 1, 2, and 2. And then I would write the components of my second vector below it. And then what I do, to find the first component, I cover the first component and do the calculation like a 2×2 determinant. So I multiply these two, it becomes 2, minus these two, it becomes minus 2, so it becomes 4. And then I would write 4 here. But the only exception that you need to remember, the middle one starts with the negative sign and do the same thing, meaning that I cover the middle column and then do the calculation as before. 1 minus 2, 1 times 1, remember that, minus 1 times 2, so the answer is minus 1. But there is also another minus sign here, so this becomes positive 1. And then for the third one, there are no exceptions again. So I cover that one, I multiply these two, it becomes minus 1. I multiply these two, it becomes 2. I subtract them, it becomes minus 3. So 4, 1, and minus 3 is my vector. So if I want to write it more properly here, I write it as a column vector. So it's 4, 1, and negative 3. And then if I want to calculate this, so this means that I have a 1/2 here. Now I have a square root of. The norm of this vector actually means 16 plus 1 plus 9. So then it becomes what? 26. So it becomes 1/2 square root of 26 area units. So that is also the surface area of this triangle. For the third one, we are supposed to find an equation for the plane containing my triangle. So if you have studied your lesson so far, so you know that in order to write an equation of a plane with some properties, we need to look for two things in the problem. One thing is that I need to find a point which I can convince myself is on my plane. Here we have actually plenty of them. For example, assume that this is the plane that I am looking for, and this is supposed to contain my triangle, yes? This is supposed to contain my triangle. So, in order to write an equation for the plane, you need to know this. You need to know one point which is on the plane, and then call it X node, Y node, and Z node. And you need to know a vector which is orthogonal to the plane. The length of the vector is not important. In which direction it is actually perpendicular to the plane is not important. What matters is that it should be perpendicular to your plane, and then this is called a normal vector for your plane. So let us consider that the components of that normal vector, you can somehow find A, B, and C to be A, B, and C. Okay? So you find these three, and then you have to know this equation that this is proven in the book, why this is the equation of the plane that contains this point and is perpendicular to this vector. Y minus Y node plus C Z minus Z node is equal to 0. It's an important equation to know, okay? So my goal is now to find X node, Y node, and Z node. I don't have anything to do, yes? I can choose any of these points, the coordinates of any one of these points for X node, Y node, and Z node. It doesn't matter. So I would prefer to use this because I have 2 zeros. Working with that might be easier. So I would say that, okay, so X node is 0, Y node is 2, and Z node is 0 again. But if I ask you what is A, B, and C, you would tell me that this is the component of one normal vector to my plane. And I hope that you know that what we did here, we actually cross product AB and AC. And you know that when you cross product these two vectors, it becomes a vector which is perpendicular to the original vectors, both of them. If that is the case, so this means that AB cross AC is a vector which is perpendicular to AB and AC, and consequently it is perpendicular to the plane. So it can play the role of my normal vector. So in this picture, so assuming that this green one is AB, and of course this black one, for example, is AC. In this case, if I cross product A and B, if I really want to know the direction, of course, I need to use the right-hand rule. So I have to bend my fingers on the right hand in a way that it goes in that way. So, and then my thumb will actually point towards the direction of the cross product. But as I told you, what matters here is perpendicularity, not the direction. So this, I hope that by this explanation, you realize that the components of this can play the role of A, B, and C correspondingly. So I would say that A in this problem is 4, B is 1, C is -3. And then I put them in that formula. What do I get is A, which is 4 times x minus 0, and then I have +1, and then I have 1, y minus 2, and then I have -3, and then I have z minus 0 is equal to 0. And then, of course, I simplify that. So it becomes 4x because they have mentioned to move the constant term to the right in the problem itself. So to respect that, I write 4x plus y minus 3z. And then you see that I have a -2 on the left. I move it to the other side. So this is my equation that I was looking for. Okay? One exercise for you is I recommend you to solve the problem but change the point. The intermediate steps might be different because the values that you choose for x node, y node, and z node are different. But you see that after doing the calculations, you will reach to the same, or sometimes not exactly the same equation, but an equivalent equation, so that by multiplying by an appropriate constant, you can change the form of that equation to make that equation looks like exactly this equation. I really recommend you to do that. You don't learn mathematics without doing it. Okay, but now I also want, this is the problem, the solution to the problem is actually finished here. But let me also solve this problem algebraically. Yes? What do I mean by algebraically? Because they have asked you to find an equation for the plane of this form. Okay? Here we had some kind of geometrical method in back of our head. For example, I realized that AB cross AC, which we already know what is the meaning of AB cross AC, in this context is the vector that I am looking for, namely the normal vector of the plane. So I have some kind of geometrical intuition to solve that problem. But let us forget about geometrical intuition and now solve this problem purely algebraically. Okay, so I want to find an equation like this, which we know that's an equation of the plane that is supposed to pass through those 3 points. So in other words, those 3 points are actually lying on the plane. So what does it mean? It means that the coordinates of these 3 points should satisfy this equation. So if I replace x, y, and z with x, y, and z of coordinates of any one of these points, I should get a correct equation. I should get a valid equation. Okay. So for A, I replace x with 0, replace y with 2, and replace z with 0. What do I get? I get 2b is equal to d. And I do it once more for 1, 4, and 2. So I replace x with 1, I replace y with 4, and I replace z with 2. I get this equation. And then finally, I replace x, y, and z with 1, 1, and 1. Then I will get this equation. Okay, so what do I have now? I have an algebraic system to solve, but I have only 3 equations in 4 unknowns. So I have 1 degree of freedom left, so I will have a free parameter in the problem. Okay, so what do I do? So let me write everything in terms of d. Okay, so I decide to write every one of them in terms of d. So I divide by 2 this equation. I get b is 1/2 d. And then I put it here. So this becomes a plus 4 times b means 4 times this quantity, which becomes 2d. And then I have 2c is equal to d. And I move 2d to the other side, it becomes a plus 2c is minus d. Okay? I do the same thing here. So I replace this b with d over 2 here. So this becomes 1 plus 1 over 2 d plus c is equal to d. What I do, I move 1 over 2d to the other side. So it becomes a plus c is equal to 1 over 2d. And then I have a system of equations having this equation and having this equation. So I'm pretending that d is given and I'm trying to solve and find a, b, and c in terms of d. Okay, so in order to solve that, I multiply this by a minus sign and add it here so that I can get rid of a's, and then it becomes c. If I multiply this by a minus sign and add it here, it becomes minus 3 over 2d. And then, for example, I put it back in this equation and then move it to the other side. It becomes positive 3 over 2, 4 over 2, so it becomes 2d. Yes? Okay, now I have b, c, and a all in terms of d. Okay, so what can I do now? I can say that, okay, my equation is supposed to be this. And then instead of a, I put 2d, so this becomes 2dx. Instead of b, I put 1 over 2dy, and then instead of c, I put minus 3 over 2z is, minus 3 over 2d, and then z is equal to, okay? Now I divide everything by d, so I will get 2x plus 1/2 y minus 3z is equal to 1. I multiply everything by 2, it becomes 4x plus y minus, I forgot to put 2 here. I multiply everything by 2, so it becomes 3z is equal to 2. And then if you compare this equation with that equation, they're exactly the same. Okay, but of course, the whole point of this course is to understand the algebraic calculations from a geometrical perspective as well. So I myself prefer to solve this problem in this way, but of course this is also completely valid a way of calculating things, and you see that the answers are actually the same. Yes? Of course, I should be careful when I want to divide everything by d. I have to make sure that d is not equal to 0. But of course, if d is equal to 0, I have an identity. Yes, if d is equal to 0, b and c and a are all 0, then I have 0 equals to 0. So this doesn't give me an equation of any shape. So if I want to get the non-trivial answer, then I assume that d is not equal to 0, because if d is equal to 0, a, b, and c are also equal to 0, then I will get 0 equals to 0. It is not inconsistency, but it will not give you any kind of non-trivial answer. So in order to get a non-trivial answer, which is in this case the equation of a plane, so I have to assume that d is not equal to 0, and this justifies dividing by d safely. Okay? Okay, so I hope that this video was useful. Until the next video, be safe and goodbye. Thank you.